Hi class, this is Mr. Morris. I'm just continuing our video on the final exam review. This is the second page starting at number 15. This is talking about the periodic table and a matching section with the groups on the periodic table, group 1A, 2A, 3A. And we've got these names, nitrogen, alkali, metal, and so on. So just to remind you, these letters and number combinations at the top of the periodic table tell you what group it is. This column is group 1A, 2A, 3A, and so on. So group 1A, this first group, it's called the alkali metals. Alkali metals. We're going to put B. And then group 2A, the one right next to it, is the alkaline earth metals. So this group, alkaline earth metals, that would be E. 3A, well, boron and aluminum are at the top. So you look through the options. It's either going to be the boron group or the aluminum group. I see aluminum, so I'm going to put aluminum group. Group 4A, if you look at the top, it's got carbon. Carbon's at the top, so we go with carbon group. So some of these are kind of obvious. You get to group 5A, nitrogen, nitrogen group. But these last few, so the last three and the first two have a special name that's not just an element, it's at the top. Group 6A, this one's not very common, but this group right here with oxygen, sulfur, selenium, it's called the chalcogens. D, spelled with a CH. Chalcogens. Group 7A, a little more common. That one's called the halogens. G. And then group 8A is called the noble or inert gases. Noble gases mostly. C. So we go on down. It says to predict whether the ionization energy, which is the energy required to remove an electron, of the following elements will be more or less than that of nickel. And then we want to explain why using the following reasons. So we've got all these reasons. Keep in mind, energy levels, this is going to be what row it's in. Greater shielding effect, that's also still talking about the row that we're in. These two are if they're in different columns or groups. So if we go on down, we can look at it. Platinum, the first one. Well, let's see. Platinum is PT. It's right here. Nickel, where is it compared to nickel? Well, it's directly below it. Directly below nickel. You're looking directly below it. Electronegativity and ionization energy are both what we would call a snow cone trend. So that means it's going to decrease as it moves down. And then if we were to tip this snow cone over, it would look like this. So it increase going from left to right. So this one is below it. So platinum is below nickel. Therefore, it would have a lower ionization energy. The reason is because it's in a different row. It's in a different row, and it has more energy levels, not fewer. It's further down, so it's a higher row number. Greater shielding, so we're going to put 2 for our reason. Chromium, Cr, is right here, nickel's right there, so it's to the left. Chromium, again, is going to have less shielding, or lower shielding. I'm sorry, lower ionization energy. And the reason, in this case, is because of a weaker effective nuclear charge. Effective nuclear charge is going to increase as you go across a row. and then germanium, Ge, and Ni. Well, germanium's farther that way, so it's going to have a stronger effective nuclear charge. It's going to have a higher ionization energy because it has a stronger effective nuclear charge. And by the way, this all, if you're wondering, where does this come from? This comes from periodic trends notes. It's a good place to refer for these questions. And we continue on. This one is saying the larger atom, that's going to be atomic radius. Atomic radius. This is what we would call a snowman trend. It gets bigger going down, or if we were to push the snowman over, it would look like this. It would be smaller as it's going from left to right. Okay, so snowman trend for atomic radius. So we just want to compare these and just know which is bigger, cesium or platinum. Well, cesium's right here. Platinum is way over here. Cesium is closer to the left. That's going to be bigger. Cesium is bigger. All right, Ti or HF? Ti, well, that's thallium. Let's see. Ti is titanium. There it is. Ti or HF? Hafnium right there. So as we go down, it gets bigger. So hafnium is going to be bigger. As we go down, it gets bigger. Hafnium is bigger. As and S. So I know where S is. It's right here. As is right there. So again, as we go from left to right, it's getting bigger. And as we're going, it's getting smaller. It gets smaller going this way. It gets bigger going down. So this, it's bigger down here. It's smaller this way. So that means this one's bigger. Arsenic is bigger than sulfur. Okay. And then we have Ln. I'm sorry, that's not Ln, that's iron. So IN or P. So IN is right here, and then phosphorus is up there. Well, which one's going to be bigger? Indium is bigger. All right, then we have this. By the way, this is still periodic trends. For each pair, circle the atom with a smaller effective nuclear charge. Okay. Effective nuclear charge has to do with the number of protons. So Na or P? Well, you have Na here, P is over here. Which one has a larger, does it say larger or smaller? A smaller effective nuclear charge, Na or P? Well, effective nuclear charge increases going across, so that means Na has a smaller one, so we're going to circle Na. In E or O, well, we have Ne here, we have O there. Which one's smaller? O. Al or S? Aluminum, sulfur. Aluminum is going to have the smaller effective nuclear charge. Rn or Ra? Rn is here. Ra, Ra is right there. Well, Rn is much farther to the right, so it's much farther to the right. Ra has another layer of electrons shielding it. Rn is far over to the right side. It's going to have a greater effective nuclear charge. So we're going to go with Rn as the greater, which means Ra would be the smaller. This one's probably the trickiest one. Okay, for each pair, circle the atom with the lower electronegativity. Okay, electronegativity is going to be a snow cone trend, just like this up here. Which one has a lower electronegativity? Lithium or francium? Well, we have lithium way up here, francium's at the bottom. Snow cones decrease going down, so francium's got the lower. Na or Cl? Na is here, Cl way over here. So that means Na is going to have a lower electronegativity. Snow cone increases going across. Argon or chlorine? Ar is here, Cl is there. Which one's going to have a lower electronegativity? Well, electronegativity, and I forgot to remind you of this, noble gases have 0 electronegativity. 0. So that means the lowest electronegativity is going to be argon as a noble gas. Sulfur or strontium. Sulfur is here, strontium is way over here. That's a pretty big difference. The biggest difference is going that way. So which one's lower? Well, strontium is way over there. Sr has a lower electronegativity. For each pair circled atom with a higher ionization energy. So that was what we talked about up here, ionization energy. Again, a snow cone trend, without exceptions actually. So for each pair, we want to circle the atom with a higher ionization energy, the higher, cesium or platinum. Cesium's here, platinum is over here. If increase is going this way, platinum is going to be higher. Higher ionization energy. Ti or HF. HF is here, Ti is there, Ti is higher. As or Br. As, Br. Br is higher. Ne or Kr. Right, we have Kr, we have Ne. So if this was electronegativity, it would be a trick question because it would be 0 for both. But this is ionization energy. Krypton is lower, neon is higher. All right, and finally lithium. Oh, this is talking about circle the atom or ion with a larger radius. Okay, you got to keep in mind the thing that determines the size of the atom is actually electrons. The number of electrons, because the electron cloud is much bigger than the rest of the atom. So we got to decide which of these has more electrons, lithium or lithium plus. Well, lithium plus is lithium after it's lost 1 electron. So lithium has more electrons. That makes it the bigger, the atom or ion with the larger radius. So sulfur or sulfur minus 2, which one has more electrons? It's going to be this one. Sulfur with a negative 2 charge. Calcium ion or calcium atom, which one has more electrons? Calcium does. This one's lost 2. And then which of these has more electrons? Will be the bromide ion, Br minus 1. The more the electrons, the bigger the atom. And that's the second page of your review.